All right, in this video, I have a very common word problem that you will see in a systems of equations unit of algebra. Something along the lines of talking about animals on a farm or just animals in general. And one of the animals is gonna have 2 legs, the other animal is gonna have 4 legs, which means we can write a system out when given this information. There are chickens and cows on a farm. And for those of you wondering if I drew these, you better believe it, I did. Yeah, buddy. There are 41 heads and 132 legs in all. Okay, so 41 heads, well, each of the animals only has 1 head, but 132 legs, that's where it gets confusing because chickens only have 2 legs, cows have 4 legs. So we're talking about 2 different types of animals and totals that have to connect to them. So we're gonna write our equations out in standard form, ax plus by equals c. And by creating a system of 2 equations, we can figure out how many cows and how many chickens there are on the farm based off of this information. So the first equation I'm gonna write, remember I need to make 2 to make a system. The first one is gonna have the total of legs, 132 legs. Now, if I'm talking legs, I need to attach a number to each of these because cows have 4 legs, so I'm gonna say 4x. Chickens have 2 legs, so I'm gonna say 2y. Now, what I would recommend you do is label your variables early in your problem. If we put a 4 on x, we're talking about the cow. If I put a 2 on y, I'm talking about the chicken. Okay, so now we know what x is representing, we know what y is representing, but we need one more equation before we can get going in solving this. The other equation is going to be talking about a total number of heads. There's 41 heads on the farm. Okay, well, each of these animals only has 1 head. So we could say 1x plus 1y, but whenever we have a 1 as a coefficient in algebra, you don't need to show it. We need to just understand that when we have variables all alone, there's 1 in front of each one of those terms. That's just common knowledge in algebra by now. So now we have this system set up. We can solve it using the substitution method, elimination method. If you wanted to graph this, by all means, go ahead and graph it. I think the best way to solve this system, however, is eliminating. In order for us to eliminate, we got an x here and a 4x there. We'd want those to match, or we want these to match. I'm gonna match up the bottom equation by making y a 2y. The way I would do that is I would have to multiply all 3 terms by 2. So 2 times x is going to make 2x. 2 times y is going to make 2y. And 2 times 41 is going to make 82. Now, if I erase this middle equation that we created, you'll notice now that my system has identical matches with the y terms, meaning we can eliminate. So I'm just going to rewrite the same equation up a little bit higher so I have room to work down. 2x plus 2y equals 82. Now I can erase this information and start working down. Okay, when we're eliminating to solve a system, if this is plus 2y, this is plus 2y, and both of those terms are positive, you need to subtract to eliminate them. They're gone. Y's have disappeared, leaving me just with x's. So 4x minus 2x leaves me with 2x. 132 minus 82 leaves me with 50. We've got a 1-step equation we can solve by just inverse operating. Now I know x is equal to 50 divided by 2, which is 25. Now remember at the start of the problem how I labeled x as cows, y as chickens? When I get down here and I say I have x equals 25, I know I'm talking about the cows. So let's move on over here and write 25 cows. Sorry about that. A little dad humor for you. Okay, x equals 25. Now if I have 25 cows, let's make it simple. Good mathematicians, somewhat lazy, right? We don't necessarily have to put 25 back into an equation because we know there's 41 total heads. If 25 of the heads are cows, how many more do we need to get to the total of 41? Yep, 16 chickens on the farm. Hopefully this makes sense. Study hard and good luck on your upcoming test.